Welcome to the Ultimate Mathematics Exam Strategy Explainer. We affectionately call this session the boxing match, because honestly, sitting down for a complex Cambridge 0580 math paper is exactly like stepping into the ring. Float like a concept, sting like evidence. Your answer combinations have to be perfectly timed. Today, we're tearing into a real review exercise and looking at two very different types of students. First, there's Alex. Alex overloads his answers with raw mathematical facts, writing down every formula he knows, but he completely lacks structural analysis. Then we have Sam. Sam rushes, completely misses the command word requirements, and just starts mashing buttons on a calculator. We're going to look at their flawed red ink-covered answers, correct them live, and build you into a champion mathematician. And this right here perfectly illustrates the challenge we're up against today. Two dense pages of past paper questions pulled directly from Review Exercise 3. It's a lot, right? On one side, we have a barrage of financial mathematics and exponential growth models. On the other, we're hit with time calculations, algebraic manipulation, and the dreaded irrational numbers, surds. When Alex looks at this, he panics and just vomits formulas onto the page. When Sam looks at this, he skips reading the actual question and dives straight into the numbers. Both approaches lead to disaster. But today, we are going to transform those red marks into green check marks by decoding exactly what the examiner wants to see. We are going to systematically conquer this review exercise by breaking it down into four crucial masterclasses. First, financial exam mastery. Second, calculating rates and time. Third, exponential growth and decay. And finally, simplifying complex surds. Okay, let's jump straight into section 1, financial exam mastery. Navigating percentages and interest. This is where command word decoding becomes absolutely critical. In Cambridge mathematics, a word like calculate doesn't just mean guess the answer. It means you must show the precise numerical pathway that leads to your conclusion. And to do that, we use the PEAL framework. Point, evidence, explanation, link. The point is your core formula. The evidence is your raw data. The explanation is your step-by-step working. And the link ties it all back to the specific command word in the question. Now, check out this classic spot the trap scenario. We've got Daniel earning simple interest and Tanya earning compound interest. Alex almost always messes this up by applying the exact same logic to both. Let's use our PEL strategy instead. For Daniel, the point is the simple interest formula, principal times rate times time. The evidence is $1,200, 2%, and 6 years. The explanation. We multiply 1,200 by 0.02, which gives us $24 a year. Over 6 years, that's $144 in interest. Finally, the link. The command word says calculate the amount of money in the account, which means we have to add that $144 back to the initial $1,200, giving a final answer of $1,344. Easy, right? Now look at Tanya. She invests $8,500 at 3.1% compound interest for 5 years. Sam completely ignores the word compound and calculates it just like Daniel's. Huge mistake. The point here is the compound formula, principal multiplied by 1 plus the rate to the power of time. The evidence, 8,500 multiplied by 1.031 to the power of 5. The explanation working gives us $9,815.93. But wait, there's a second part. She takes out $9,300 for new equipment. The final link is subtracting $9,300 from $9,815.93, leaving her with $515.93. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving on to question 7C. When calculating Henry's holiday money, we've got to follow these 3 precise steps to secure all 3 marks without getting completely lost in the exchange rate of $1 equals 0.44 euros. Alex tries to do this all in one massive chaotic calculator entry and loses all his working marks. Don't do that. Let's structure it logically. Step 1, convert the start money. He has $850. To get to euros, we multiply by the rate. 850 times 0.44 equals exactly 374 euros. Step 2, evidence of spending. He spends 260 euros, so we subtract that from 374, leaving him with 114 euros. Step 3, the return trip. We must convert that 114 euros back to dollars. Since going from dollars to euros was multiplication, going backward is division. 114 divided by 0.44 gives us $259.0909. But pay attention, the command word explicitly says, give your answer correct to the nearest dollar. Sam always misses this instruction. The correct finalized answer is exactly $259. Let me break down why so many students absolutely bleed marks on question 7b. Carlos sells his bike for $231 after making a 16% loss. Sam looks at this, calculates 16% of $231, and just adds it on. That is a fatal error. The 16% loss is on the original price, not the selling price. If he lost 16%, it means the $231 represents exactly 84% of the original cost. So to find 100% original price, our explanation step requires us to divide $231 by 0.84. When you execute that cleanly, it perfectly unpacks to $275. By working backward from the loss, we reveal the original price was exactly $275. This is how you outsmart the exam paper. All right, let's roll into section 2, calculating rates in time, mastering speed, and schedules. We're going to see how our framework builds into real-world applications of time, distance, and wages. This is where pacing yourself and handling time-based questions is a real game changer. Get ready for a quick data scan challenge. To calculate Leah's hourly rate from her $682 weekly pay in question 7a, we first have to map out her daily shifts to accurately find her total hours worked. The command word is calculate Leah's hourly rate. Our point is the formula, total pay divided by total hours. The evidence requires us to find those total hours. Her morning shift runs from 8:45 to 12:15. If we step up to 9 o'clock, that's 15 minutes. From 9 o'clock to 12 o'clock is 3 hours, plus 15 minutes to get to 12:15. That is 3 hours and 30 minutes, or 3.5 hours. Her afternoon shift is from 13:15 to 17:30. 13:15 to 17:15 is exactly 4 hours, plus 15 more minutes to get to 17:30, which is 4.25 hours in decimals. Adding 3.5 and 4.25 gives us a solid 7.75 hours per day. Now, can you spot the flaw? You have to be incredibly careful here. Simply subtracting 8.45 from 12.15 mathematically on your calculator will cost you the exam mark. Why? Because time operates on a base 60 system, not base 100. This is the exact trap Alex falls into every single time. He types 12.15 minus 8.45 into his calculator and gets 3.7. That is fundamentally wrong, and it completely ruins the rest of the question. Stick to the base 60 reality. So, back to Leah. She works 7.75 hours a day for 5 days. 7.75 multiplied by 5 gives a weekly total of 38.75 hours. Finally, to find her hourly rate, we divide her total pay of $682 by 38.75 hours. The result? A perfectly clean $17.60 per hour. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back into it. This brings us to question 6b, which tests your ability to convert units before plugging them into the speed, distance, time triangle. The question states the distance between Foxby and Glanton is 15 kilometers, the bus takes 12 minutes, the command phrase is, calculate the average speed of the bus in kilometers per hour. Pay incredibly close attention to the units requested. The distance is already in kilometers, but the time is in minutes. Let's do a speed writing challenge in our heads. You cannot just divide 15 by 12 and get the right answer. Sam rushes and does exactly that, ending up with 1.25, which makes absolutely no sense for a bus on a highway. Instead, we have to convert 12 minutes into hours. 12 divided by 60 is 0.2 hours. Now apply your point formula. Speed equals distance over time. 15 kilometers divided by 0.2 hours yields exactly 75 kilometers per hour. A perfect, logical, peel paragraph answer. Moving right along to section 3, exponential growth and decay, modeling the future. Let's put everything into practice by extracting the core trend from a complex formula. We are transitioning from static numbers to continuous exponential changes over time. Look closely at how every variable in this exponential formula holds specific extractable data for finding the bacteria population. Look at question 3. The formula given is p equals 1200 multiplied by 1.03 to the power of t. Question 3a asks for the population on 1 January 2018. Well, if t is the number of years after 2018, then on that exact start date, t is 0. Anything to the power of 0 is 1, so the population is simply the initial 1200. Boom, 1 mark secured instantly. For 3b, calculating the population on 1 January 2022. The year 2022 is exactly 4 years after 2018, so our evidence is t equals 4. We plug this into our point formula, 1200 times 1.03 to the power of 4. Your calculator will give you 1350.61. Since we are talking about a living population of bacteria, rounding appropriately gives us 1351. Notice the stark contrast here. The bacteria population steadily climbs year over year, while the CAR's value aggressively drops by 50% every 2 years. We've seen the growth. Now let's find the flaw in how students handle decay. Question 4 states the value of a CAR decays exponentially, halving in value every 2 years. At age 4, the CAR is worth $42,000. Alex looks at this and assumes that if it halves every 2 years, in 4 years it halves twice, so he just divides $42,000 by 4. No way. We need to structure our logic meticulously to work backward. If the CAR is worth $42,000 at age 4, reversing the halving process tells us it was originally worth a staggering $168,000 when new. Let's structure this flawlessly and create a timeline. At year 4, the value equals $42,000. To go back 2 years to year 2, we do the opposite of halving. We double it. So at year 2, the CAR was worth $84,000. We double it one more time to go back to year 0, when it was brand new. Double $84,000 is $168,000. That is how you secure all the marks for 4A without getting tangled in complex logarithmic reverse formulas. Just clear, undeniable logic. For 4B, we go forward to age 10. From year 4 to year 10 is 6 years, which is 3 periods of 2 years. So we have the $42,000 3 times. Half of 42K is 21K. Half of that is $10,500. Half of that is $5,250. This leads perfectly into 4C. David has saved $10,500. Work out the age of the car he can afford. As we just proved in our timeline, the car hits the $10,500 mark exactly at age 8. Pure, step-by-step logic wins the day. Let's move to section 4, simplifying complex surds, the final frontier. It's time to see how to tackle the most abstract challenge on the paper, manipulating irrational numbers, or surds. This is question 8 on the review exercise, and honestly, it's where many students simply throw in the towel. But not you. You are going to use our structured approach to dismantle these expressions piece by piece. To secure the mark for question 8A, we have to eliminate that square root of 6 from the bottom by rationalizing the fraction. The question asks us to rationalize 5 over the square root of 6. Sam looks at this, panics, and tries to turn it into a decimal. Do not do that. Command words involving surds expect exact, irrational answers. The point here is the mathematical rule. Multiply both the numerator and the denominator by that exact same square root. The evidence, multiply top and bottom by root 6. The explanation, the top becomes 5 root 6, the bottom becomes root 6 times root 6, which is just the integer 6. The link to the final answer is perfectly formatted, 5 root 6 all over 6. One clean, clear mark. Now, question 8B requires a multi-stage simplification to match the specific integer format requested by the examiner. It asks us to simplify 3 over the expression root 7 minus 2, and we must give our answer in the form p plus q root 7, where p and q are integers. This requires a very specific tactic, using the conjugate. By methodically applying the conjugate in these 3 steps, we completely dissolve the complex fraction into clean integers. Step 1. The conjugate of root 7 minus 2 is root 7 plus 2. We multiply the top and the bottom by this expression. Step 2. Expand the top. 3 multiplied by the group root 7 plus 2 becomes 3 root 7 plus 6. Step 3. The denominator. This is a classic difference of 2 squares. Root 7 times root 7 is 7, and minus 2 times positive 2 is minus 4. The middle terms cancel out perfectly, so the denominator is simply 7 minus 4, which equals 3. Finally, we take our numerator, 3 root 7 plus 6, and divide it all by that 3 on the bottom. The 3's cancel elegantly, leaving us with root 7 plus 2. Looking back at the command requirement, p plus q root 7, our p is 2, and our q is 1. The fraction has been completely defeated.
Whether you're decoding Tanya's compound interest or rationalizing complex surds, your success lies entirely in your structural approach. We've shown you the complete mathematics answering system today. You have 3 rules that guarantee top marks. Number 1, command word decoding. Know the difference between calculating simple interest and simplifying an algebraic surd. Number 2, our adapted Peel framework application. Always establish your formula, point, plug in your evidence data, explicitly show your working explanation, and link back to the final required format. And number 3, the time management matrix. Don't rush like Sam and make silly decimal errors, but don't dawdle like Alex writing out useless facts. Pace yourself using the logical steps we just practiced. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @aceexams_IGCSE and click that bell. Don't let another exam pass you by. Until our next explainer, take these structured strategies, grab a past paper, set a timer, and pretend you're stepping into that boxing ring. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here. So I'll leave you with this. Which of these 4 mathematical masterclasses will you use to tackle your next past paper?